Hello friends, my name is Deepak Omprakash Dakle. Today in this lecture we will study the construction, working and applications of stepper motors. These motors are called stepper motors as they rotate through fixed angular steps. Friends, when we talk about stepper motors, we call them as special purpose machines since these machines are designed to perform special functions. That function cannot be performed by simple AC or DC motors without using closed loop feedback. It means if we have to use AC or DC motors in order to perform these functions, then we have to use some closed loop feedback along with them. As we can see over here, that the function of the robotic arm is to pick an object from one conveyor belt and put the object at the other place on the other one. For such applications where precision is the most important factor, we use stepper motors since they have the ability to rotate in small discrete steps in accordance with the applied train of pulses. These train of pulses are nothing but digital control signals generated by some controller. Stepper motors control the angular position of the rotor without any feedback loop. Today's automation industry is solely relies on stepper motors as they provide precise speed control or precise positioning or provides both. Stepper motors are electromechanical devices which convert electrical signal into mechanical movements. Stepper motors are simply brushless DC electric motors. The basic difference between DC motor and that of a stepper motor is that a DC motor starts rotating continuously when DC voltage is applied to its terminals. On the other hand, a stepper motor is a device which converts a DC voltage pulse train into a proportional mechanical rotation of its shaft. The DC voltage pulse train can be applied through any controller. The shaft of the motor rotates through a fixed angle for each discrete pulse. This angle through which the motor shaft rotates for each pulse is called step angle and is represented by beta and expressed in degrees. For smaller step angle, the number of steps per revolution will be higher, giving accuracy of the position. Step angles can be as large as 90 degrees and can be as small as 0.72 degrees. So when we talk about precise positioning of stepper motor, we use smaller step angles which gives higher resolution. Stepper motors are also called synchronous motors since the rotation of the shaft is in synchronism with the applied train of pulses. Now we check the construction features of stepper motor. Similar to any other electric motor, the stepper motor also has two common parts. One, the stator, and second, the rotor. The stator is the stationary part while the rotor is the movable part which has no windings, brushes and a commutator. Basically there are three types of stepper motor. The first one is permanent magnet type stepper motor. This permanent magnet type stepper motor has wound stator poles and the rotor poles in this case are permanently magnetized, having cylindrical shape. The second one is variable reluctance stepper motor. The variable reluctance stepper motor, it also has the same wound stator, same as that of permanent magnet type, but the rotor in this case is non-magnetic. The rotor is made up of ferromagnetic material like iron. The third is hybrid stepper motor. This hybrid stepper motor, it also has the same wound stator poles. It combines the features of both permanent magnet type as well as variable reluctance type motor. The rotor is of permanent magnet type and axially magnetized with a radial soft iron teeth. So we have seen the stator construction is similar in all the three types, only the rotor construction is different. When we normally talk about stepper motor, we have to consider it as permanent magnet type stepper motor. Now we'll see the working of stepper motor. The stepper motor works on the principle of electromagnetism. As we can see in the figure that the stator has uniform teeth around its perimeter and containing a specified number of poles. Each pole has a winding that is connected to the opposite pole on the stator. In order to understand the working of stepper motor, we have to consider a train of pulses as shown in figure that is applied to the stator winding. Due to the applied signal, magnetic field is developed in the stator. This magnetic field results in the opposite poles to get magnetized with the opposite polarity, since we have already connected opposite poles together. The rotor of the stepper motor is made up of permanent magnet. There is attraction between the stator and the rotor poles. Since the opposite poles attract while equal poles opposes, and as the stator poles are fixed while rotor poles are movable, the rotor moves with the revolving magnetic field of the stator. This is the basic principle of operation of stepper motor. Now, the applications of stepper motor. Since the stepper motors able to provide precise speed control, direction, or rotation and angular position, they have lot number of applications. Some applications are shown such as factory automation, packaging, material handling, aerospace industry especially in avionics, 3D picture acquisition system, laser measurements and robotics. Thank you.